Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Make sure to stick to the end of the problem where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 5 to the power of x plus 2 is equal to 4 to the power of x. So the first thing I'm going to do is I'm going to take the ln on both sides, or natural log. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So for ln 5 to the power of x plus 2, I can move x plus 2 to the front. So that's going to equal x plus 2 times ln 5, which is equal to, for ln 4 to the power of x, I can move x to the front. So it's going to be x times ln 4. Now, if I distribute ln 5 with x plus 2, I get x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now, I'm going to subtract both sides by x times ln 4. So now I have x times ln 5 minus x times ln 4 plus 2 times ln 5 is equal to 0. Now, if I subtract 2 times ln 5 on both sides, these two cancel out. Now I'm left with x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. So now if I factor out x from x times ln 5 minus x times ln 4, I get x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now, if I have something in the form ln a minus ln b, this is the same thing as ln a over b. So ln 5 minus ln 4, that's going to equal ln 5 over 4. So I have this is equal to negative 2 times ln 5. Now, I can move this negative 2 to the front of the 5. So now I have x times ln 5 over 4 is equal to ln 5 to the power of negative 2. Now, 5 to the power of negative 2, that's the same thing as 1 over 25. So now this is equal to ln 1 over 25. Now, if I divide both sides by ln 5 over 4, these two cancel out, and now I'm left with x is equal to ln 1 over 25 over ln 5 over 4. So this is my answer. Alright, so I have x to the power of x to the power of 6 is equal to 144. So I want to find the value of x. So to start, I'm going to take the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, these two are interchangeable, meaning this is the same thing as a to the power of n times m. So now, if a to the power of m times n is the same thing as a to the power of m to the power of n, then a to the power of n times m, this has to equal a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we have x to the power of x to the power of 6 to the power of 6. We can think of x to the power of 6 as m and 6 as n. So now we can switch these two places. So now we have x to the power of 6 to the power of x to the power of 6 Now this is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal the variable y. So now I have y to the power of y is equal to 144 to the power of 6. Now 144, this is the same thing as 12 to the power of 2. So now I have 12 to the power of 2 to the power of 6. And remember, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 times 6 is 12, so I have y to the power of y is equal to 12 to the power of 12. Now if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 12. However, remember, we're not solving for y, we're solving for x. And x to the power of 6 equals y. So now that we know that y is 12, this means that x to the power of 6 is equal to 12. So now, to solve this, I'm going to take the power of 1 over 6 on both sides. So now I have x to the power of 6 to the power of 1 over 6 is equal to 12 to the power of 1 over 6. Now 6 times 1 over 6, these two cancel out. So now I'm left with x is equal to 12 to the power of 1 over 6. So this is my answer. Alright, so I have 2 to the power of 20 minus 1. Now 20 here, we can rewrite this as 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. Now if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 10 times 2, that's going to equal 2 to the power of 10 to the power of 2. Now I have this minus 1. So now 1 here, this is the same thing as 1 squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10, and b is equal to 1. So I have 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now, 2 to the power of 10, this is equal to 1024. So now I have 1024 plus 1 times 1024 minus 1. 1024 plus 1, that's going to be equal to 1025. And 1024 minus 1, that's equal to 1023. So now I'm left with 1025 times 1023. So now, let's go ahead and evaluate this. Well, first off, 1025, to make this simpler, we can rewrite this as 1000 plus 25. And 1023, we can rewrite this as 1000 plus 23. So now we have 1000 plus 25 times 1000 plus 23. So to solve this, I'm going to start by distributing the 1000. So now I have 1000 squared plus 23 times 1000 plus 25 times 1000 plus 25 times 23. So now 1000 squared, that's going to equal 1 million, plus 23 times 1000 is 23,000, 25 times 1000 is 25,000, and 25 times 23, that's going to be 575. So now if you add all of these together, you get 1,048,575. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 7 to the power of x is equal to 70. Now we can first start by converting 70 to 7 times 10. So now we have 7 to the power of x is equal to 7 times 10. Now I'm going to divide by 7 on both sides. So now we have 7 to the power of x over 7 is equal to, these two cancel out, so simply just 10. Now, if we have something in the form a to the power of m over a to the power of n, this is simply equal to a to the power of m minus n. So 7 to the power of x over 7, this would be 7 to the power of x minus 1. And now this is equal to 10. So now what we're going to do is we're going to take the log of both sides. So now we have log 7 to the power of x minus 1 is equal to log 10. Now, the power property of logarithm states that I can actually move this exponent here to the front of the log. So now this would be x minus 1 log 7 is equal to log 10. Now I'm going to divide both sides by log 7. So now these two cancel out, and I get x minus 1 is equal to log 10 over log 7. Now, if I add 1 on both sides, I get x is equal to 1 plus log 10 over log 7. So this is our answer.